so let's go to the next session. So we know that quadcopters is a technology with a big future. Actually, I think that we are going to have in the future a lot of drone delivery in our cities. But the problem of the robots, of the quadcopters right now, is that they are very big, they are very expensive, and they don't work with ROS. But none of those problems are in the quadcopters that are developed by the company Bitcraze. And this is the robots that Bitcraze creates are quadcopters, especially for research and education, and they are small. So today we are going to have a lesson with Kimberly McGuire, who is one of the robotics engineers at Bitcraze, and she's going to teach us how to program quadcopters, basic stuff with ROS too. So thank you, Kimberly, for coming here to the stage. Hello, Kimberly, are you there?
Yes, I'm here. Are you able to hear me?
Yes, we can see you.
Great.
And then, hello. I think that you cannot see me myself, but anyway, so I'm super happy to have you here. Then we are going to start with your presentation. So can you please share your screen?
Of course.
Yes.
Are you able to see my screen?
Yes. Yes.
Awesome.
Okay. So go ahead. The stage is yours.
All right, great. Thanks you, Ricardo, again, also for inviting me to give this talk or this tutorial here at the Robotics Developer Day. Yeah, like you said, my name is Kimberly McGuire. I'm a robotics engineer at Bitcraze. We're the developer of this small quadcopter called the Crazy Fly. Yeah, so it's going to be a tutorial. So I'll try to, or like a skill learning session, as they call it here. So I'll hopefully be able to learn you or teach you a couple of things. Um, Among those things is an introduction to the multicopter plugins that are natively present in Gazebo, how to add velocity control and able to control it with ROS2, how to add sensors to your model and read them out in ROS2, and how to make a simple map out of that. And yeah, perhaps also to show that on a real platform as well. So my understanding, are you guys still able to hear me?
Yes. So what?
Awesome, great.
Yeah.
I had I got an error. Okay,
Okay. No, no
reset.
problem.
So the preliminary knowledge that I think that you should at least know to kind of follow along as you can is that you should have some basic knowledge on ROS2 aspects, like for instance, like ROS topics, ROS services. Perhaps you might have touched Gazebo a little bit, or you followed one of the courses here on the construct. So this ROSject, if you're following one of the hands-on passes, is configured to be on ROS2 Humble, and it has Gazebo Fortress enabled in there as well. So yeah, so this presentation would also be showing some demonstrations on a real Crazy Fly quadcopter. So that is that's the one that we at Bitcraze have developed for research and education. So if you happen to have a Crazy Fly with you with a positioning system, and you've prepared it to run this ROSject, then that's great. But you don't have to. I would actually advise you, especially with perhaps like the severity of the servers, maybe to cut the construct some slack and maybe try them out later. But it's absolutely possible. So, all right, so that's the intro out of the way. And first up is part one, is a bit about quadcopter dynamics. And we're going to forget about ROS2 for a bit, and let's just look at the Gazebo simulator for now. I'm talking about the new Gazebo, so not Gazebo Classic. I have here some codes or like some instructions or commands that I can do in the terminal right here. And then I'll start up a Gazebo simulator with a quadcopter model. It might be for some of you, if you're just opening up your ROSject for the first time, that it has some time, that your simulator might need some time to start up. But at least you'll be able to see it here already. Let's zoom in a bit to right click on the Crazy Fly and move to. So that kind of looks like a standard quadcopter. It's It's based on the X1 quadcopter of Gazebo Fuel, but it has like a crazy fly skin on it. So it's so that's kind of like what it looks like right here. So this is based on a simulation model. So if I open up the code editor, which is this symbol right here, which is a kind of like a visual codes editor that they use here, we can perhaps take a bit of a look at the model itself. So you can find that in ROS2 WS in source, and then you can look at ROS GC Crazyfly, ROS JC Crazyfly description, and model. This is the part that I had to source in my terminal before in order for Gazebo to find it. And yeah, practically it's not as maybe as complex as like an armed robot. It only has like 5 features, which is a base link that is connected to 4 motors with a revolute joint, so that you can kind of see right here. So like M1 is motor 1, motor 2 is all connected to the base link. And what is perhaps more important, because you don't only want rotating motors, you want the motors to actually do something, you have this plugin called Multicopter Motor Model plugin from Gazebo, where you can actually give it some aerodynamic characteristics, which means is that if the propeller rotates, it will actually generate an upward force, which we call thrust. And that's pretty much kind of like the basic of how you can make a crazy fly or a quadcopter fly. So you have 1 plugin per motor, as shown right here. So let's open up a shell. And yeah, let's see. So this is where the Gazebo is running from. So let's open up a new one. I will just copy paste this part of the commands and open up the Crazyfly simulator here. All right, so let's see what happens if we spin those motors, shall we? Ah, it spins right away. I have noticed that sometimes you need to do this command a couple of times for it to react on the Gazebo side, but for me, it's worked right out of the box. Awesome, so the propellers are spinning. Great, but it's not flying, really. So let's change that a bit. How about 100 RPMs machine? Yeah. Let's crank that up a notch. Let's just see it happens. It's in simulation anyway, right? So 1,000 each. Ah, it's not really flying yet. Oh, where did it go? Uh-oh. I lost my simulated quadcopter. That's not great. Okay. Yeah, let's check the pose a bit.
So,
It's going all the way up. Yeah, that's whoops.
can I help you?
I did that on purpose, actually.
Ah, okay.
Yeah, I fooled you. Because this is kind of a lesson in safety. Because imagine if this would happen in a real quadcopter. If I just tried it on my quadcopter right here, it would have hit the ceiling. Or if you would have done it outside, it would have been like, well, go up all the way in the air, hit a bird, hit a plane. So that is extremely dangerous. So yeah, luckily we tried it in simulation. That's the power of simulation. And also kind of like the main difference between quadcopters and ground-based robots. If I would stop the motors of the simulated quadcopter now, it would just fall out of the sky. Yes, so I was locked out. Hello?
Yeah, it looks like we are having some problems here in the login.
One moment, let me just, okay, let me just do that here. We'll solve this. Constructs.
Yes, so what are you doing there? Because the screen that shows is very strange.
Yeah, it's a VS Code on my computer side.
Your own computer. Okay. So
exactly. If everything fails, then that's perhaps what we can still do. But I'm now currently logging in. Let's see the time, perhaps.
yes. So
Well,
can you
I
try
might need
again,
to.
please?
It's currently still yeah. One
No,
moment. I'm almost there.
we cannot.
I can.
Yeah, we cannot see your screen. Yeah. No. Sorry. Yes. Okay.
Yeah, I'm not. It's taking a long time.
Yeah.
So, but we'll get there. So
Okay.
yeah, I guess like I can just keep on talking on the like.
Yeah.
Ah, that is unfortunate.
So,
Yes.
yes, I'm sorry about that. So it looks like we are having a lot of requests, and for some reason, so there has been an overloaded on the database, and we are trying to solve it as we are speaking here. And then the same happened to me actually. And then well, I was monitoring your ROS and following you, but then I also got kicked off. So
Yeah,
at least
apologize to everyone
yes.
for that. We're
It's
trying to
not your
log back in.
fault. It's not your fault. It's our fault. It's our fault, definitely. But as you can see, the system doesn't discriminate against the speakers or
Yeah.
anybody else. So we are suffering all the
We're
same
all
thing.
affected by it,
The same boat.
as it seems.
Yes.
Um,
So what can you tell us about Bitcraze?
Yeah.
So what are you
let's
working
turn
now?
this into a tiny interview then. Yeah. So Bitcraze is a small company that is located in Sweden. So like we're kind of known for the Crazyfly. That is this one right here. But we also kind of like do make expansion decks for the Crazyfly so that they can do some positioning with a flow deck. I'm currently showing it with the lighthouse positioning system, which I can probably also give a long talk about, but maybe not now. And that is actually a positioning system that's based on virtual reality. That's also kind of like the bundle that we are giving away for one of the for the price for the prizes that you can get for participating with this the Robotics Developer Day.
Exactly. Afterwards, after your presentation, so we are going to show the video about Bitcraze and all the amazing things that you are doing. They are going to love it because the images are spectacular of the drones in different situations. And the winner of the question at the end of the video, they will win your package that your company is providing, which is the tiny drone, the real one with the place for recharging and also the positioning system.
Exactly. Yeah. So so it is possible to recreate all the demos that I'm going to show to you right now.
Yeah.
Hopefully.
Yes.
Let's see how things are going.
Yes. So let me ask you. In the meantime, that this is. So let me ask you some questions related to the.
Sure, of course.
So,
so in any case, I can probably skip over a couple of things just to get to the end. But once because I guess we need to be a bit straight on time. But we can.
Don't worry. We'll take charge of this, and then I will guide you on this purpose. Okay. Don't worry. Don't worry. So let's wait that this. Let's hope that this problem is solved quickly by the technical team. And then let me ask you one question about. So what are the main applications that your customers are using the quadcopters for?
So the main applications I would say is like it used to back in the day. It used to mostly be people that like to develop by themselves, like the hacker society. But it's mostly the demographic has changed now to researchers that use it for their own research. I myself used the Crazyfly also for my PhD research, where I had like a swarm of them flying through an indoor building by themselves, and so that was my PhD topic. And people use it for like control theory. They use it for swarm research, like swarm robotics research. They use it for single drone based autonomy, which I'm hopefully able to show a little bit. Also, that's there's also quite a lot of people that use it with ROS as well. The Crazy Swarm 2 is the project, at least the Crazyfly server that I want to show to you. I'm just going to refresh.
Yes, and then
page.
in the demonstration that you are going to use, because we were preparing this together, so kind of I know what is coming, but I was amazed of the demonstration that you were going to do, and all the audience also were always able to do it together with you by using the project, which is about this tiny drone doing a map of the environment by itself. So can you tell us more about this application?
Perhaps maybe, well, this is reloading again. I can maybe show a picture of or a video.
Yes, or a video that you show me. Yeah, that would be awesome.
Yeah, so I've also showed, I also had a recording of my earlier rehearsal as well.
Yes, because you prepare that for the case of emergencies, actually.
Yeah, exactly. So this is one of the demos, spoiler alert, that I was going to show. Hopefully still are able to show. Oh, wait, maybe I can get in now.
Oh, okay.
Yeah.
Let's have a look. Let's see if this is getting in.
Yeah. But yeah, so like you see here, the RF is open and with like the mapping topic on. The Crazy Fly has a multi-ranger that has a range sensor that is in 4 different directions. And then you can, with teleopt, rotate it a bit around, so it can create the map within the environment as well. So that's really cool.
Wait. But can you tell us about the sensors? So you are showing there on the screen the map, right?
Yeah, exactly.
It's being created by the Bitcraze, but how does it does that? So which sensors? So how did you do it?
Let's see if I can kind of show a. Yeah, it's maybe a bit difficult to. Oh, maybe it's here. Like you can see it maybe here.
A little bit lower on the camera. Can you put it a little bit lower on the camera? Yeah, that one. Yeah, we can see.
So it's like a range sensor in 4 directions.
And this is an add-on. This is an add-on that you can put on the Creative Fly, right?
Exactly. Yeah. And then you can do some cool things like making a map. Like you don't need a very expensive lighter for that, but it's it's like at least like it's great to kind of like show the basics. And people have done research of actually doing full SLAM with such a sparse lighter as well. So those are also really cool videos if you look them up. There you go. I think we're getting somewhere.
Okay.
Let me just take a quick look at the time.
Yes. So don't worry. Don't worry.
I think I'll be able to show still some cool stuff, but I might need to skip a couple of things.
Okay, great. Go ahead. So.
But it's still loading, so we can. If you have any other questions.
Yes. Okay. So what I want to stress on that is, so the map that you are showing for me is impressive because of several things. The first thing is that it's made by using only 4 rays, right?
Yes.
Because people is used, I'm stressing this point because it's important, because people is used to use the LiDAR. So they think, okay, let's do a map with a quadcopter. Let's put a LiDAR on top that scan, and then the battery, and then, so how can you manage that? But in your case, this solution is very simple in the sense, I mean, simplifies a lot because it's only using 4 infrared rays, right?
Yeah, exactly. Yeah, so it simplifies it quite a lot. It's that is already enough to make some kind of map. But of course, you have less information about the environment, like packages like navigation, like nav2, for instance. Like I've interfaced with things like that, but it has a little bit of issues with how do you call it? Actually doing the localization part of that as well. That is quite challenging. To do that from packages that are meant for
AMCL.
Okay, I'm kicked out of my project again. Let's try it again.
Okay, let's go.
Yeah. So that is kind of like that's kind of the problem. You're not able to really do for some good localization. Luckily, I have a positioning system here, so that is not really a problem for me. But if you have a quadcopter flying in an actual real environment, without any predetermined knowledge, that's maybe a little bit more challenging.
I see. So in this case, you are using the localization provided by your positioning system in order to create the map? That
is kind of providing the odometry for the map building. but like in SLAM, you have simultaneous localization and mapping.
Yes.
So right now it's pretty much only doing the mapping, but it's still fun.
Yes.
Yeah.
And we are going to do it. So we are almost there. So has your project already started? Is ready?
No,
Not
it's
yet?
not.
Okay, okay.
It's always kicking me out.
I see. I see. So I think that we have those problems. Then maybe so. In the meantime, let's.
Yeah, I can show another video.
Yes,
perhaps.
please.
And in any case, if we still 15 minutes before time don't have anything at all, I can show a couple of things on my own computer.
Yeah. Sure.
And then at least we have something to show.
Yes. Perfect.
So this is the other demo that I want to show you. Is just like, okay, the mapping is one thing, but how do you generate a map, right? Like how do you do exploration in an environment that you don't know beforehand? You can make the map first for yourself and navigate into it, or you can explore.
Yes.
And that is kind of like, this is a video that I'm currently showing in the main screen, where you can actually see the crazy fly doing wall following. It's kind of similar to robotic. How do you say, like these robotic vacuum cleaners?
Yes.
With lidars, like they
Yes.
usually don't have a predetermined map if they're just placed in a new house. So that's kind of like very similar. What they do is kind of they go around all the walls, and then and then they just make the map while
At the same time.
they're going. So there is Rosject again. We have
Okay.
about 20 minutes.
Yeah,
Let's
let
see
me
how
see.
far
It's 37, so we should end. Let me see. It 55. Yeah, we have 20, 50, 60 minutes.
All right. So let me just get a recap of what I've been at, let's say, when we last started. So like, we had a gazebo simulator, we had a quadcopter. I gave a little bit too much trust, and then goodbye. So that was to remember that be safe with your quadcopter. It's not a wheeled robot. It will fall out of the sky, or be safe. That's why we have a simulator. So let's see like how far we can get with this. But at least for the simulation, I would need to also not only have trust, but also provide some form of control. This is the multicopter control system for velocity control. It's already pre-tuned before, but that's I can unfortunately not go into it too much. So I would advise you to look at the API documentation of Gazebo and the multicopter systems. So yeah, so now at least my simulator should be able to fly a little bit better and not fly away. So let's just start up I'm just going to build it again with a ROS2 and Gazebo bridge. That's all part of the code, and hopefully Kokon will build. And it's building right now. If you've run through the starting tutorials of ROS, then you are already familiar with those comments. So yeah, then we should have actually something that's a crazy fly that's able to fly a little bit more stably. So I'm just going to show that real quick, but not in much detail. So let's give it a twist message to the controller, and let's see what happens. So it will go up with 0.1 meters per second, which is not very quick, but at least it's controlled. It doesn't fly away. So I'll just give it a 0 velocity command, and then it will stay nicely in the air. Awesome. I don't expect you at this point to follow the tutorial that quickly. Unfortunately, I have to go pretty fast, but you can refollow this, at least this project afterwards.
Yes, don't worry about that. So just go do it yourself.
Exactly. Yeah. So like I said, I'm going to show it also on the Crazy Fly, but I'm going to show that for a later demonstration because I'm really little on time. So once I make the actual hardware demonstration, I will go through what I'm actually going to show to you. So we have, at least for simulation, we have now a more controlled quadcopter, right? So it's not flying away, it's able to respond to velocity messages. Now we're at the place that we want to be, to at least make it act like a wheeled robot, perhaps. So we add this tiny lidar that I've already showed on the camera before, with the impromptu, let's say, the impromptu interview. And here it's a GPU lidar gazebo sensor that has like 4 range sensors in all directions. And what I'm going to add that is to the base link of the gazebo simulator. So I'm going to put that here. Awesome. And I'm going to show some simulation mapping. So first, Brazenham is a pip package that needs to be installed, because that is something that the simple mapper node is not one of the nav2 or ORBSLAN packages. We use our own package that we have installed, or at least like we have on this project, which is the simple mapper one. And then if you would open up Gazebo, I don't want to rename it. I want to maybe open up Gazebo again. Did I? Yeah, there you go. At least you'll be able to kind of see the lidar visualization right here. So you might need to reload it a bit. There you go. LiDAR result. But there's not a lot in the environment to map. So let's change that. Let's add some walls to it. And that is not done in the Crazyfly model, because that's the model of the Crazyfly. You do that in the world. So now I add 4 walls to the world. And then I build everything again to make sure that everything is properly assigned to the install folder on your ROS workspace. And then now you see a couple of walls. Well, let's do some mapping, let's say. So I have now, because I've just Cocom built it, I can start up a mapping node. And then I can show RVis too, if everything works. Right, let's add a map. That looks nice, but a bit empty. Let's change that. I need to make it fly a little bit. Let's do that. Okay, so I can make the Crazyfly fly, make stop in air, make it go forward, maybe a bit quicker because we're low on time. And I hope we don't crash it. Luckily, it's simulation. Yeah, so it's a bit, you can see the Crazyfly right here. I hope it's not too small. It also needs to be not flying over the walls in order to map it. And then it goes all the way like there. I guess you guys get the point. I'm now currently controlling it with teleopt in order to do the map. But the Crazyfly hasn't, or the simulated Crazyfly hasn't crashed yet. So there'll be, maybe if I look at the time, yeah, a good opportunity maybe to show this on the real platform. But yes, kind of that's most important part, of course. So yeah, I would have been sad if I wasn't able to show you guys this. And I have a couple of extra demos planned. But let's see how we do on time.
Yes, you are on time. Don't worry. You are doing
Awesome.
excellent. And this is the main conclusion, because it's when you are applying this to the real robot.
Yeah, exactly. There is some more concluded parts. I went through it very quick, so I should have enough time for the last part as well, to show a bit of autonomy too. I'm just going to restart the Crazyfly, and I am also going to change let's say the camera, because I have a nice camera setup, I don't want to move my computer and to show it to you.
Let's see if we can combine somehow the camera. Okay, yeah, now we can see you in the camera, yes.
Yeah, exactly. So this is the meeting room. This is my my life now. Let's see if we can. I've now restarted the Crazyfly. I'm now going to start the server outside of this ROS-ject. But if you start a ROS2 node on your computer or a robot that's connected to, that's connected through this part from the ROS-ject, then you're able to control it from a web shell in the ROS-ject as well. Let's do that very quickly. I can also control it with tailor-op twist keyboards, just like I was able to with the simulator. And let's make it take off and hope for the best.
Okay, let's see.
There you go.
There it goes.
Yeah,
and you are controlling,
kind of
now
right?
we cannot see your screen, but we can you switch now to the, oh yeah, so this is your camera on your laptop, and then you can see the robot there. Awesome.
Yeah, exactly. So this is not my this is actually my phone.
Your phone. Okay, your phone camera.
Yeah. So it's
and you are getting the data on the ROS-ject. Sorry.
Yeah, yeah. The ROS-ject, I'm just controlling it a bit. Maybe I'm going to start up a how do you say, a mapping on my ROS-ject as well.
Yes.
So you can switch back. If
sure.
Yes.
That would be awesome.
So I'm going to start up the mapping nodes. Let's see. So it's mapping. Obviously, you don't have to have this many printouts, but I like it for debugging myself. And let's start up an RVis 2 as well. Yeah. Oh, whoops! I didn't save it. Save this, but that's fine. It's very easy to get it. Oh, there you go. It's already started the map. It started without me. Too quick. Too quick. All right. Let's make it rotate a bit, right?
Yes.
Ooh.
Awesome. Getting the map. So that's just to remind the audience. So this is inside your ROS-ject, and you are getting the data from the real robot.
Yeah, exactly. Yeah, so I'm controlling currently the real robot from my computer. So just as a kind of like a reminder to everybody is, oh, one of the walls went down. I need to fix that before I show this next demo. But it's not running ROS on the Crazyfly itself. But there is a really cool embedded project called from eProsima that put micro ROS on the Crazyfly. So I have the link right here in the notebook. But that is, but currently the Crazyfly is being controlled from a ROS server on the computer. But it doesn't mean it doesn't run ROS. It doesn't run natively ROS. But yeah, that is just a very quick explanation that I had to skip. Awesome. Let me just take it down and maybe prepare for the last part. Fortunately, I had to, I think it's most important for me to kind of show you the concept and then always, let's say that you're able to perhaps try out the ROS-ject for yourself as well. So you will be able to go through all the code. There's no problem. It's all going to be available. And I also have a GitHub repository outside of that you can also try out your ROS-ject. But let's first disconnect again. I just want to try something out in simulation first. Because mapping is really cool, and it's pretty cool on such a small platform with such a sparse slider. But like what I said before, also in the interview, is that wouldn't it be cooler if you're able to navigate without a map and generate a map while you're at it?
Yes.
So that is kind of like the true part of like exploration autonomy, right?
Yes, exactly.
Yeah. So that is. So I'm just going to.
Because so far you have been moving the robot using the keys, right? You're controlling it.
Exactly. Yeah. Exactly. So that is, and that is that robotics? Maybe. Well, I feel that robotics needs a little bit more autonomy.
Yeah.
I'm just still disconnecting from the Crazyfly, so let's hope that everything goes well.
Okay, I don't expect the best. in there.
All right, something went wrong.
Yeah.
Right.
Yes. So my team is doing a full reboot of the system, so maybe that's because of that. So
yeah, exactly.
Yeah.
In that sense,
In that
perhaps if we're not connecting to it anymore, I can still show the simulation, but I'll just turn off the drone just to be
Okay.
sure, because to make things easier for myself, it's responding to the same things.
Yes. Okay.
But maybe not the safest. Please don't use the same topic for velocity command for a real crazy fly and a simulated crazy fly. Just
Why?
pro tip.
Why?
Because if you happen to work on simulation and then you just suddenly forget that your drone is still on,
Yeah.
then you might also send it to your actual drone as well.
Yes, exactly. And then, and then you can make something crazy because the real environment maybe is different from the other one.
Yeah, exactly. So that is just. So I'm not able to disconnect from my computer, but that's fine. I have dealt with this before. So I'm going to go through the autonomy part that I've told you, and that autonomy part is just very simple. It's going to be wall following based on the multi-ranger. Just kind of like you technically only need 2 multi-rangers in order to do wall following. And that's kind of how it here goes. It rotates when it hits the wall, and then it goes around the corner right here. So yeah, there's a couple of nodes where you can, which I don't have the time to go through all the codes, but you can find it all, like the wall following node here and the simple mapper right here in the ROSject.
Yes.
But hopefully we'll be able to show it to you.
Let's see, with a little bit of chance, the whole system is rebooted and we can reload it. And with the bad chance, then let me ask you some questions in the meantime.
Oh, I'm already connected.
Okay.
That went quicker than expected.
Okay.
Yeah, the only thing is that what I'm hoping for is maybe that's the ROS. Yeah, I guess like I didn't. If it was saved from the last position, then.
Okay, excellent.
Oh, whoops.
I think that you need to launch it again, but now the system has been rebooted, so it's going to work without a problem.
Yeah. All right. I thank everybody for being so patient.
No, I'm so sorry about that. That you are suffering this and how much
it's fine.
preparation.
It's a good challenge.
And your reaction is awesome. It's awesome. So thank you very much.
So it's I guess like this is also kind of a lesson in the demo effect.
Yeah, well,
and
you know that we are doing this. So our conference is about real demonstration exactly. In real time, and you went harder as more so even harder than most of the people, because you are going with the real robot, not just the simulation but the real one, and then you nail it.
Yeah, so. Exactly. And yeah, so like the complexity is not helping, but I'm committed to finish all the demos before the end.
Go for it. Go for it. You got it. Your mood got it.
We're going to do it. Okay. Wall following. Wall following is awesome as long as you have walls and range sensors. So I'm not going to go through the code. I'll leave that up to you guys. I'm going to show it first in simulation because we like safety. And yeah, so let me just first bring up the Crazy Fly simulator. I hope that everything is still in the same state as when it just closed down, but I'm just assuming it is. So let's launch up the Crazy Fly simulator with walls. There are walls. Awesome, awesome. Everything is going swell. Okay, and then I'm just going to very quickly make it take off with the teleop. So just to make sure that's a bit more near. There you go. And then I'm going to start the wall following. So a lot of, as you know from me, a lot of printouts. And it's actually going in a different direction, but let's see if it's able to react on it as well. Actually, it's it seems to be not working. But that's fine, because the real thing will work. It's actually responding a little bit differently. Oh, it's actually doing the wall following. Oh, phew. Okay, nothing wrong. Nothing wrong. It's just that the simulator is probably a little bit running a bit faster than I'm when I prepared this project. But that is perfect.
Yes, that
Okay,
is
so wall
right,
following
because you
is
have a more powerful computer.
exactly. So currently it's doing the wall following. Let me just make it go a little bit closer. Maybe make it follow it as well. So it's using the range sensors for that too. But actually what we want it to do is also to do mapping at the same time. So let's start up the ROS2 simple mapper again. Let's open up RVis2 as well. And add the map. And then you can see, if I make this a little bit bigger, that it's generating the map while it's going around the room. Technically, there's a small bug in here. It should also generate a map when the sensors are not detecting anything, but I leave that to an exercise to the people that are actually following this project. But yeah, it's kind of like making a map right now, and I'm not doing anything, no hands.
Very good.
So yeah, let's close everything, and let's also show this on the real Crazy Fly.
So what are you going to show right now, just for the audience that was disconnected a little bit about it? What are you going to show on your real Crazy Fly?
On the real Crazy Fly, I'm going to show exactly the same thing. So what I'm going to show is that I'm only connecting to it from my computer, but the wall following node is exactly the one that I'm using in this simulator right here from the ROSject. So the ROSject is controlling the drone completely autonomously. So that's what I'm going to show.
Excellent. I'm excited to see it.
Let's put the Crazy Fly back as well. Maybe change the meeting room. So we can show this in time.
Now we can see your environment.
Exactly.
Don't worry, you're on time. Don't
Awesome.
worry, really, don't worry.
So yeah, so this is then the environment. I'm going to make a takeoff like I did before with the teleopt from the ROSject. So wait one moment before I need to kind of see if the server is on. And also, let's just check if any topics are being... Oh, topic.
Can you show her screen? You have to be switching about.
So yeah, there you go. So you see you see all the topics from the real Crazy Fly being received by the ROSject. So that's awesome. So that means is that we can control it from it as well. So let's make it just simply take off. All right. And then, of course, like before.
Now go back. Oh, sorry.
Let's make it follow a wall. And if you go to the camera now, you can kind of see it. Let's see if you're able to see it. Yeah, there you go. Navigating completely by itself from a node that is running from the ROSject.
We can see it. Awesome.
Yes. Oh wait, of course. We're forgetting one very important thing, which is maybe you want to do some mapping as well, because that's also very important. And let's also very quickly open up RIS.
Switch back. Yes.
RVis2 as well, because we don't want to miss this.
Vamos a ver eso.
There you go.
Yes.
So now I have a real Crazy Fly. I'm not controlling it. See? No. Hands-free. And it's navigating autonomously. It's generating a map while it's at it. Yeah, this is kind of what robotics is all about, right?
Awesome. It's awesome.
Something that's able to control itself, move autonomously based on its own sensors, and do something useful while navigating in an unknown environment. So, yeah.
Awesome. So thank you very much, Kimberly, your amazing ending of the demonstration with a real robot moving autonomously, creating the map. everything in ROS too. Thank you very much, Kimberly.
Yes. I have some closing words, perhaps. Let me just grab
Yes,
the
definitely.
crazy fly real quick.
Yes, so we are seeing how you grab it from the air right now.
Yeah, exactly.
So-
Like, there's a way for me to safely land it, but currently the crazy fly luckily is safe enough for me to do these kinds of things.
It's manually.
So yeah, but don't do this with a big drone. Warning.
Yeah. So, yes.
So like, how much time do I still have, Ricardo?
5 minutes.
5 minutes. Okay, I think that's. Is that for with questions as well?
Yes, but you, given your situation, you can go ahead and do your final thing in the way that you like. Please go
Yeah.
ahead.
Because I do have one final demo to show, which is not in the project itself, but it is kind of like, it's kind of like the
Sure, go ahead.
big wow.
Go ahead.
I'm first going to go through the conclusions, then I'm going to end with the final demo, and hopefully we'll have a couple of more minutes for questions.
For questions, yeah. Excellent.
So just kind of to conclude, like I showed one crazy fly simulated and one real crazy fly in the real world, where we kind of like alternated between the simulated application and the real application. And that's a very important tool to have when you're doing robotics development. And it will accelerate also your development by so much. You don't want to only work on hardware for sure. When I was making this wall following node, I also alternated between simulator and the real crazy fly. And that's just the way how things have to go, not only for safety, but also for your sake as a robotics developer. There's a couple of things to consider. I simplified a lot of things in this tutorial. 40 minutes is not a lot, or 55. So there's a couple of terms that you kind of also need to know when you want to work with quadcopters and simulators. Like the sim to real gap is very important. The positioning, like how you get positioning, is very important. Also, always think about enhanced safety. Crazy fly, sure, it's a bit safe, but if you have a bigger quadcopter, make sure you have an emergency button for the real thing. That will react on it no matter what. Also, kind of ROS2 project management. I started all the ROS2 nodes by myself. I did that on purpose to kind of show you what's actually going on. But you can all manage that in one big launch file. That is no problem at all. And also software in the loop is also very important. Yeah. So one final demo.
Yes. Go ahead.
All right. So I just need to do a couple of changes because this is kind of outside of the project for sure.
Okay.
But we're going to be able to see RVis, the result in RVis. So I'm just going to change a couple of things in the server.
Okay,
I'm going to
this is
down
real robotics developer
crazy flies
in real time working.
in the abstract, and this is also for Ricardo, new one. I said swarming.
Awesome.
So yeah, swarming is not really done with only one crazy fly, of course. So now let's pray to the demo gods.
Yeah, we are praying here.
Please pray. Yes. Please pray, because I'm going to do a swarm mapping.
No way. Okay.
Okay, so let's go to the. I think I should be still able to connect through the ROSject.
Yes, probably, but to only one, right? No, because you are connecting to the computer, so you can control all the robots.
Exactly. Awesome. So I'm now currently starting up. I can control them from here as well. Let's also start up RVis too. It's a different topic, so I need to add a different map to it as well. That is called merge map. Oh, there you go. Okay, everything is still going well so far. Thank you for praying, people.
Wow.
Thank you for praying.
Yeah, we are heavily praying here.
Yes. Okay, ready for takeoff.
Let's go.
There you go. And now let's make them rotate a bit.
Awesome. Wow.
All right, maybe a bit to the side. Maybe a bit to the forward. So they're not controlled by a wall following, but they are controlled by me at this moment. But they are collaborative and merging maps together. Wow. There you go.
Yeah, so the
let me
three
just,
drones doing the map at the same time.
There you go.
Awesome.
So yeah, that is was my surprise to you,
Oh,
Ricardo.
I had no idea. Yes, because we only went onto the first drone doing the map autonomously. That is awesome. That is awesome. So super cool.
All right, I think I'm done.
Yes. Thanks
So
very much.
this is definitely the last demo. I have no more. The checkbox is empty. But in the notes, there's a couple of interesting links to like the server that I used on my computer and the code I
Remove the
used for this
Kimberly
project.
thing.
So
Remove
you
the
can kind of
Kimberly
refer
thing.
to those. And also don't forget to follow like ROS2 tutorials of Arduino and Peaks4. They have great stuff as well. Yeah. Any questions? Is there still time for questions?
Yeah, let me ask you one question, okay? So
Yeah.
here there are several of people, and people, I don't know, you can see the conference screen, but they are applauding to you. There is a symbol for applauding, and then you are getting a lot on there.
Oh, okay.
Yeah.
Thanks a lot, guys. I'm not looking at the stream because I'm
Yes, it's
afraid for
understandable.
the connection. There's probably just a little bit of, but yeah, thanks a lot to you guys for
Sure.
listening and
Sure.
enjoying
You
the
have for the
process of the demo effect and the conference effect.
yeah, so much patient. Then let me ask you one question, which is the most voted one, is from Alexander Warkus that says, "What sensors are on the copter?"
What sensors are on the copter? Let's grab one, shall we? And make sure that it doesn't fly in my face.
Yeah.
So the sensors currently that's on the copter itself is an IMU. So there is a gyroscope, not a magnetometer, but an accelerometer that's on the drone itself. And then you can also add decks like the multi-ranger that was doing the mapping. That's something that you can add on to the quadcopter itself. And then suddenly it's able to also detect ranges as well. This is a deck that is able to detect the light sweeps from the lighthouse positioning system. So this enables actually to have the Crazy Flight do onboard positioning. So that's also a sensor. We have a whole bunch of sensors. Like for instance, if you don't want to set something like this up, maybe a flow deck is better for you.
Yes.
With optical flow and a range sensor. So then you can kind of have something that is able to fly by itself without a external
Positioning
setup.
system.
So, yeah.
Okay. Okay, then unfortunately we don't have more time for questions. We have several here, but we have to switch to the other one. Thanks so much, Kimberly, for your excellent presentation, awesome preparation, and I apologize for all the trouble you suffered, but you reacted so awesomely. Thank you.
Yeah, I'm glad that I was able to show all the cool demos. I think that was the most important, and we got it out. So I'm
and
happy.
He's recorded.
Yes, awesome.
He's recorded. Yeah. Thank you very much, Kimberly.
All right. Hey, bye everybody. Thank you for listening.
Thank you.
Yes. Thank you, Kimberly. Very nice. Guys, I want to take a quick moment to let you guys know that we apologize for the technical issues we've been having. We've been working on the background to get them solved. So please now, you should be able to refresh your browsers, log back in if you had those issues for the people that are asking in the chat. You also might have seen a box on the chat where you can actually rate the. I think I'm having an issue here with the noise. You can rate the speaker. So please take a moment to do so.
Yes. So.
All right.
No, you are having problems with the mic, so no, we cannot hear you. The people cannot hear us. So, hello.
There we go.
Okay.
I think we're back.
Yes.
Good stuff. So yes, again, make sure you take a moment to rate because at the end of the conference, we will be selecting the best speakers based on your votes.
Yes.
Definitely. Now, before the next speaker hits to the stage, let's have some fun again.
What's that?
So we're going to do another quiz prize right now. And how does this one work? So we're going to watch a 5-minute video about a robot product by Bitcraze. And at the end of the video, again, you will see a question related to the product. So the first person who answers correctly in the chat will win a crazy fly quadcopter like the one you saw in the presentation, plus a charging system station and a positioning system. So you may need to go to the page of the sponsor to get to the answer. So now let's watch the video, and the next speaker will be back in 5 minutes.
See you soon.
See you soon.